We are very fortunate to have Nick Stans, who is the past VP of ISA Standards and Practices. He's an ISA fellow and also a fellow at DuPont, to give us an overview and his insight into the use of ISA standards. And I think we have not been utilizing them as effectively or understanding them as much as we should. They offer an awful lot of guidance and really very useful information for us to do our jobs and do it much better in a much more productive and effective way.
Good morning and good afternoon, or perhaps good evening to everybody online. My name is Nick Sands, as Greg said, and I am past Vice President of Standards and Practices, and today's talk is around the amazing secret world of ISA standards. A lot of those standards are public, but I will still disclose a lot of secrets around the standards today as we go through this. And it is meant to be interactive, so I'm going to ask you some questions, and the fun of all this is to hear your answers and participation. So please be ready for that. Be ready to unmute and chime in. So I thought what I would go over is a little bit of the history, some of the background of ISA standards, how to access them, and how to join a standards committee. So and then we're going to spend some time talking about some of the hottest standards today, and then again, how can you join? You can be a part of this. So ISA and ISA standards. Standards was one of the important parts of ISA from the very beginning. So ISA was founded right after World War II. There was a lot of innovation in simulation and control technology that was done in World War II, but a lot of things couldn't be published because there was a lot of secrecy. There wasn't a lot of scientific sharing or engineering sharing during the war. And so in Pittsburgh, Pennsylvania, there was a group that had been working on instrumentation and control, and a lot of other places, Philadelphia, and these guys all got together and formed, and they were mostly guys back then, indeed, formed the Instrument Society of America. So we started off with that in 1944, and by 1945 they had issued their first recommended practice. That's what RP stands for. That's part of our secrets. They issued a recommended practice 5.1 on instrument flow plan symbols. So this is the beginning of some of our standards, which are really the basis of a common communication in many cases, so that we can understand from one engineer to another, from one automation professional to another. So the world's changed since 1949. We've been at this for a good while, and today ISA is the International Society of Automation, and it's accredited by ANSI, the American National Standards Institute, as a standards development organization. So ISA creates American national standards. So those are U.S. national standards, and then it's also we partner with the International Electrotechnical Commission. And I know electrotechnical looks like a made-up word, but it's not. So the International Electrotechnical Commission, IEC and ISO are the big standards development organizations, and if it's around electronics, technical standards, it's normally going to be an IEC standard. So we work with primarily Technical Committee 65, a subpart of IEC that looks at automation. So ISA writes standards that are both American National Institute standard, American National Standards, and also go in to become IEC standards. So that's a lot of responsibility. So we do set global standards, and then we have a lot of people from around the globe that are involved in that. Over 4,000 people. Not all ISA members. Don't even have to be an ISA member to be part of a standard committee. About 140 different committees and working groups and things like that. So there's a lot of places to be involved, and we're going to go through some of those. But first I want to show you, so I think pretty much everybody on today's call is an ISA member, and that's good. hope you continue to be a member. I've been a member for 27 years, I think, so been around for a while. On the ISA website, there's a part for standards and publications, and underneath there is the place where you can view ISA standards as a member benefit. So you can see all of the ISA standards, and there's some caveats to this, but you can see all of the ISA standards, recommended practices, and technical reports for free. You can view them. You cannot download them, but you can view them. We, for a brief period of time, made them available for download, and then they were all over the internet, and so we had to withdraw that. But there are some that we adopt from IEC. So a lot of ISA standards are adopted by the IEC, and some of them from IEC we adopt into ISA. And when we do that, we don't own the copyright, and we can't make those viewable. So you cannot see the IEC adopted standards for free as a member benefit. But all the ISA developed ones you can. So how do you become a member of an ISA standards committee? That also is fairly easy. There is a place on the website, and it's actually further down on the same, on the standards and practices, there's another gray button with a box, and it says, join an ISA standard committee. When you do that, it's going to ask you which one do you want to join. So the first thing you actually want to do is go see what committee you want to join. And there's a page that gives a description for every committee. You can just Google search for ISA standard and then whatever topic keywords you want, and it'll take you right to one of those pages. So that's how you can go join. There's no requirement to be an ISA member. There's no requirement to travel. A lot of the committees do the majority of their work by email and conference call. And so you can be a full, active, contributing, participating member of a standard committee and not travel. Now, if you're able to meet some of the meetings, and some of them, those committees have face-to-face meetings, you get to sit down face-to-face with some of the world's leading experts in that topic. If you go to the ISA 84 committee meetings, you will sit down with the top experts in the world on safety instrumented systems. And if you go to the ISA 18 committee meeting, you will sit down with the world's top experts on alarm management. So those committees have, really top experts in the field of automation in these different subjects. It's not the place for you to go to ask introductory questions of what is alarm management? What is a safety instrumented system? That's not a topic to bring up at one of those meetings. If you're going to come to that standard meeting, you need to be ready to play in that field. But you can go and listen and learn and get to know people, and then become acquainted with the topics that they're discussing, and work your way up to the person that's asking the questions and making the comments, unless you've already got that level of expertise. So you don't have to be an expert to join, but you want to make sure that when you're asking questions, they're relevant to the conversations at hand. So just a comment there. But again, free to join. Yep. So what kind of standard committees do we have that you could join? Well, it's a wide range from instrument and devices to system security. So we'll go over a few of these hot topics in alarm management. In the ISA standards today. Just looking at the alarm management one. That always strikes my fancy because I'm the co-chair of that committee. But there's quite a number of hot topics, and we've published documents on all of these topics already, but work continues, so we'll do that. So as we go through this, we're going to start with some questions here. This is time for you to participate. First, is anyone online involved in an ISA standard committee today?
Yeah, this is Bill Thomas. I'm on the 101.
All right, Bill, excellent. And enjoying that HMI discussion?
Yeah, just not as involved. Had a lot of project posts. I'm not as involved as I'd like. I'm hoping to pick that up.
All right. ISA 101. That's a good one. Anybody else?
Dale Reed here.
Hey, Dale. Boy, you could list a whole number of them, couldn't you?
In addition to 101 HMI, 106 procedural control for continuous processes, and 18 on alarm management. And for those of you who are interested in things that are not alarms, we're forming a working group on alerts and notifications and prompts and all that other stuff that's not per se alarms per the definition. So you're going to want to get in touch with me if you're interested in that stuff as we go forward.
Excellent. Thank you, Dale. And thanks for working on that, taking the lead on that working group. Anybody else online that's involved with ISA standards today?
Yeah, it's Greg McMillan.
Greg.
I'm not involved in one of maybe the more recognizable ones, but I am involved in testing the dynamic response of control valves. So I think that's ISA 75.25. And I've been involved for that for quite a long time. I hope to get a little bit more involved because I've done some testing and come to some realization of maybe better what we really need in terms of knowing how a valve responds.
Interesting. And Colin Langford on that committee with you?
Yes, although I think he's largely retired, but he appreciated my article. I wrote an article for Control magazine called Valve Response, Truth or Consequences, and trying to open up eyes. And I think they changed the title a little bit, and so the Truth or Consequences actually became an extended version of a white paper. But yeah, you can go back and look, I think, at how do control valves affect loop performance as being a Control magazine article last spring.
All right. So let's change the question now. Who's using ISA standards, and if you are, which ones are you using? Anyone?
Yeah, this is Bill Thomas. We've been looking at 18.2 here lately.
That's a good one to look at. Anybody else using the ISA standard?
Yeah, JC, just about all of them, special instrumentation, 5.1, 12.6, all the 12s, the 75s, the valves, just probably at least a third, half of them for instrumentation in particular.
All right. Well, the 12s, we've transferred ISA 12 committees to UL because it's much more electrical in nature, and so that we had to try to refocus our effort as we add some of these new committees, and it left us having to transfer the ownership of those. But those have been great standards for a long time. Yeah. Anybody else?
I don't know how many people think they're using standards, but I would bet the vast majority of you are using 5.1 in some fashion, because that's just become everybody's standard with respect to symbols and abbreviations and nomenclature.
Thanks, Dale. Danica, I heard you.
This is Danica George. Yes, we very heavily use the alarm management as well as the batch standards.
All right. Thank you, Danica. All right. Well, so let's go through some quizzes here. I'm getting some shocks. Wow.
Well, let me just mention, this is Greg McMillan. We actually use the ISA technical report and standard on valve response for our project, and it turns out that as we worked through this, we found out that it was for a steam system for, oh gosh, we had 31 feed forwards and 3 overrides and a whole bunch of let-down pressure controllers with a lot of tight control requirements, and it turns out that the valve dynamics largely determined the performance and the tuning, and also the dynamic compensation for the feed forward. So it showed just how important getting the valve dynamics right in terms of them being the best that they can be.
All right, thanks, Greg. So we're going to switch gears here now. One of the things about standards is that usually um, there's some image or figure from a standard that is highly recognizable, iconic, if you will. So we're going to go through some images of figures from different standards, and the description of the standard is there, and so Dale and uh, Greg, you guys are not allowed to guess the answers to, to these, all right? So for everybody else online, then the idea is to come up with what is that standard number and name, right? So this should be an easy one. We've talked about it a couple times already. Which standard covers instrumentation and symbology, identification and symbology? Yep. So it's 5.1, instrumentation, symbols, and identification, and it is, as Dale mentioned, it's very, very widely used. It's not an IEC standard, so it's only issued through ISA, but it's broadly used. It's not the only instrumentation symbology standard in the world, but it is pretty much the most common. So this is a life cycle figure. So different standards have life cycles. This one kind of summarizes all the activities of alarm management. So anybody? ISA 18.2, right? So this is the alarm management standard. It was originally issued in 2009, which is interesting. And if you look at the numbers, so ISA 18, the 5 committee was the 5th standard committee formed. The 18 committee was the 18th standard committee formed. And they started doing work on alarms and instrument signals back in the 40s and 50s, and there was some recommended practices in the 70s, and it wasn't until the 2000s that we really tackled the issue of alarm management. And so sometimes those issues can linger a long time, and what it really takes is enough volunteers to come together, subject matter experts to come together and drive the effort forward. So that was just reissued, by the way, in 2016. So typically there's a 5-ish year maintenance on our ISA standards to keep them refreshed. Not as frequent for the recommended practices and for the technical reports necessarily. Here's another life cycle. It's also very iconic, although it's a little bit more confusing life cycle in some ways. But this is also a very famous one. Anyone apply this life cycle very often for safety instrumented systems? What standard committee is that?
ISA 84.
It is ISA 84, right? Yep. So this was the ISA 84.00.01, initially developed in 1996 and then submitted to the IEC. And out of that developed IEC 61511, which was then adopted back. So we now have a global standard. IEC 61511 edition 2 was issued in 2016. And this year, the ISA 84 committee will be looking at adopting that edition 2 back into the U.S. as the U.S. national standard for safety instrumented systems. Now, at the time of this standard committee, the numbers were assigned for the year. So the 84 committee, the 88 committee, these committees got the numbers that started with the year that they were started, and then we stopped that. The last committee we formed was last year, and that's the ISA 112 committee on SCADA systems. So SCADA standards will be in that. And when we say SCADA, means different things to different people, but primarily the SCADA that we talk about for pipeline, where there's our remote termination units, RTUs, and you have a very distributed control network. So this is the ISA 84.00.01 standard. So part 1, there's parts 2 and parts 3. All the shall statements are in the part 1. All right, how about this one? This should look familiar to some of you. I already heard it once today.
88.
S88.
Yes, but it's not S88. It's ISA 88, right? So that's another thing that changed over time. It used to be that we had an S for the standard and an SP for the Standards and Practices Committee. So SP 88 was the Standards and Practices Committee that developed S88, the ISA standard. So now all of the standards are ISA dash for the standard. ISA, and this is, so it's wrong on this slide here, it should be a dash 88. And then ISA 88 with no dash or space is the committee. So ISA 88 is a committee, and then ISA 88.00.01 is a standard. So it would seem like we should have a standard on all that nomenclature and numbering, and it changes periodically. But this was a very powerful standard, and of course, I see Hunter's on, and he could say it better than anybody, but really tried to separate the equipment from the recipe and procedures that you were going to execute with that equipment, so that you could run the same recipe across different sites. And before ISA 88 was finally issued, what happened was everybody kind of had their own language. There wasn't any standard terminology for what a phase was or operation was or what a unit was. And this standard came together and really set down that. And so part 1 is models and terminology, and that's where they started, really defining, well, what is a batch, and what is a unit, and what is a phase, and what is an operation? And then how do we develop these models that separate what the equipment does and what the procedures do? And that was very powerful. And you can see that's some pretty abstract thinking. So some very smart people got down, but it changed the world. It changed how we do batch automation around the world. So it's a very famous standard indeed. And most standards do that. They change the world, just a very small piece of the world at a time, but they do change it. Now, this one here shows a different figure, also very iconic, about the levels of the control hierarchy, and talks about enterprise control system integration. And this work grew out of the ISA 88 work. And they said, wow, we can extend these concepts and then make more of this flow of information and describe that. Any ideas on this one?
It's 94, 95, something like that.
94.
94, 95, whatever it takes. Is that what I heard?
95, yeah.
It's the ISA 95 Enterprise Integration Control Systems. And also something that would probably be good for you to have a call on sometime there, Greg. Dennis Brandel, of course, is a great person to pull in for something like that. So this really deals with, and they started with this with a wrong way. Went with the Purdue, what was called the Purdue model, that modeled all of the business enterprise and then the manufacturing, and then within manufacturing the different exchanges of information for quality control and scheduling and all those kind of things, and those are all described in this. And then there's actually the language to be able to build those transactions so that people can use that to build these interfaces from your control system that pass that up to your SAP or ERP systems, so that you can do your production orders and all those kind of things. And I've worked in plants where when our interface to SAP went down, we couldn't ship product. So it was just important to have the electronic records of that shipping as it was to actually have the physical product to ship. And if we didn't, all those records are transmitted electronically from us to our customer. If they don't get it electronically, they can't take it physically. And So the world's some of this information flow really can control some of the business flows, and we don't get paid without it either. So it's very important for us to have that information. So that was ISA 95, and there's several parts to that as well. They started with part 1. You can see ISA-95.00.01. I should have redone the slide a little bit, but this one talks about zones and conduits for network and systems segmentation as a method of segmenting to prevent the spread of an incident. And the concept here is pretty sound, where you could have a zone, and the analogy, this is not for electrical hazardous equipment and electrical equipment hazardous locations or HAZLOC, but this is more for a network. But the analogy is there. I've got an area of a plant that's a zone 1, and I need to go to a general purpose area, and I can have a conduit that goes between those two locations and seal off the conduit to prevent anything other than the signals I want to transmit through there.
Is it cybersecurity?
Yes, it is. That's exactly right. So this is the ISA 62443 standard, 62443-2-1, Industrial Automation and Control System Security Concepts and Models, written by the ISA 99 committee. So again, we're shifting. Over the years, we've adopted more and more of the practices of IEC, and so this is one of those areas. The IEC assigned a number 62443, and our standard is issued as a 62443 standard. It's developed by the ISA 99 committee, and the number 99 doesn't go on any of the documents. All of the documents are 62443. They're ISA documents. For other parts of the world that don't write their own standards and adopt the IEC documents, they'll change the first letters. So in UK, you'll have BS 61511, which is British Standards 61511 instead of IEC 61511. They'll have BS 62443. The difference is ISA is writing 62443. So the folks in the 99 committee, they're also largely overlapped with the IEC 62443 committee, and then, which is not actually its official name, but they resolve the comments together and produce an agreed upon document. The ISA documents come out several months sooner because we don't translate it into French, and they can't issue the IEC documents until there's a French translation. So always takes a few months for that. So that's what you'll see more of in the future is ISA standards with the IEC number. Say ISA and the IEC number, even if ISA writes the standard to start with. And that's kind of deliberate to keep our documents and the IEC documents the same and to have the same number so that you don't have to keep remembering 99 and 62443, you know, so although our committees will still be probably different numbers. So this is a very important standard. It's changing the world to be sure, right? So the whole concept, if you're not working on cybersecurity today, you should be. So everything we do, there's a cybersecurity component to that in automation systems. Whether it's protecting the console so that the operator can't put things at risk, like plugging a flash drive and playing movies from home that have viruses in them. Physical security, make sure someone can't log on to the console. The cybersecurity for our networks to make sure they're isolated by firewalls so people can't get in there and take control of the process, causing incidents. So it really does change the world. This is a basic skill for every automation engineer of the future. So if you're not already getting some background in cybersecurity, it's time to start. Here's another one we heard mentioned already today a couple times. It's a new standard on human-machine interface. And again, it has a life cycle. It's not yet iconic. It's soon to be iconic, as it really does provide a framework. doesn't tell you exactly what details to put into a display, but it certainly does give you the framework for developing of it. And there's a few aspects of this, the establishing that system standard of philosophy and style guide and toolkit, and really getting after those user task and functional requirements. Those things done in a better way really make a world of difference for that whole HMI overall. So it really does provide, I think, fills in a missing gap in terms of how we were managing our HMIs and our control systems. So what number is this?
101.
It is the 101 standard. ISA 101.01. We got rid of the extra zeros. So, but you'll see we added them back later on. So, so again, a recent standard. This is a new one as well. We heard mentioned once today, procedural automation. Again, taking the concepts and the models that were developed for batch automation in the ISA 88 committee, and then extending those for continuous processes in particular. And that required, you know, some people say, oh, you can just apply the exact same thing. Well, once you get another committee in there, that you've got different people, and they needed to tweak some terms and concepts and things like that a little bit. But so much of it translated over. So this is a committee that's done a lot of work recently, and I think they've extended some of the concepts so that we'll get some good traction. Any idea what the number of this one is? All right, someone will come up with it, I'm sure, yes? Someone on mute? It's the ISA 106 committee. This is TR 106.00.01, and they went for their models and terminology for procedure automation for continuous process operations. So this one's not a standard, but a technical report.
Our second technical report is coming up on the work practices, the life cycle, and so on. So look for that coming soon.
Yep. Thanks, Dale. So in this case, it's a technical report, and what that means is that there weren't any requirements in that, and that has gone both ways over time, where the models and terminology can be termed normative and you have to follow them or not, and so that it's changed whether it's a standard or a TR. The same thing as a standard in IEC, but there are these little technical things we run into with standards, especially over time. But I think this is a pretty exciting committee, and they've got a lot of folks, especially from a lot of the knowledge from Dow, that was Dow Chemical, that really had ingrained some of these procedural automations. There was an excellent presentation at the Process Control and Safety Symposium in November in Houston, and Yahya Nasr, who's the co-chair of the 106 committee, presented that and showed how they're able to have a fully integrated plant of many unit operations and be able to schedule the startup of the entire chain of plants, because they know exactly how long it takes, because it's all automated startups for those units. So that's quite impressive. So with those kind of results out there, you can imagine people will start to go after these concepts. And it's not that you couldn't do it without the standards, but once you've got this standardized framework, again, some of these abstract concepts, smart people get in there and they write these down. It's a lot easier to follow in those footsteps and to develop it yourself. There's another exciting one that I think will change a lot of what we do in automation in the future, especially as we get more and more intelligent devices. And there is this industrial Internet of Things. So what is that exactly? It depends on who you ask, right? It's like a cloud. So whatever you look at it, or ink blot, you see something different from what everybody else sees. But there are conversations today. There are people that are working, if not producing already, working on producing um, Ethernet transmitters that work off of the same 4022 the twisted pair that we have out, so that you could replace all of your existing transmitters with Ethernet over 2 pair, and change every device that you've got in your plant to an Ethernet communicating device. So, of course, a lot of those devices today might be smart, and how much value do we get for all that intelligence? It turns out not as much as we really could, and part of that is because we don't have the work processes in place to set those devices up and say, I only need to know these things, these are the important things, and don't report that other stuff. And so that process of the procedures and practices to set up intelligent devices to be able to get the right information to get the results that you were really hoping for to start with. Turns out there's a lot of work in that. So anybody involved with the Intelligent Device Management Committee, or know the number for that one?
This is ISA 108. There is an equivalent IEC standard for this, which is SC65E led by Ian Verhassen, and I'm an information member with this committee.
So you're exactly right. It is the ISA 108 committee, and the technical report, ISA 108.1, was submitted to the IEC, and you're exactly right that it's part of Subcommittee 65E. So TC 65 is divided into subcommittees SC 65 A, B, C, and E. There is no D. And so this one is there. That's the device side of things. So yes, very good answer. And then in the IEC it can be modified and whatnot, but this was all content developed again by ISA. So originally, although a lot of people globally involved in the committee, Herman Story and from Houston and Koji Damash from Japan are the co-chairs of the 108 committee. So those are some of the hot standards that we have out there today. And we've tried to address most of the areas of automation, but we're always open for new ideas. So we pretty much say, yeah, we've got a standard for that, but if you see an area that we don't have a standard for and you think there's a strong need for one, there's another button on that website that says propose a new standard committee. Now, when you do that, we have high expectations of the research you will do before you make that proposal. So you really there's a number of questions that have to be answered. Who's going to use it? How many people are going to use it? What's the value for it? Do you have a number of subject matter experts for it? What other standards are related to that or would overlap with that? So there's a lot of questions to be answered. So it's like going to a standard committee and saying, "What's a safety instrument and system?" That's not really the appropriate question to ask in that forum. Nor is throwing out, "Well, I think you need a standard on industrial Internet of Things." That's not going to go anywhere because that's a very complex topic. Now, on that topic, we formed a committee called the Technology Search Committee to be able to parse ideas out, look forward and see what standards do we need in the future. And one of the topics we gave them to work on was this industrial Internet of Things, because it is, different things to different people. It's very difficult to boil it down to any concrete documents that could be written. And so they're working on that. They've been talking about it for a year or so, and still haven't come much closer to saying, well, we need a new standard committee to work on this, or a new ISA division to do that, or to rename the communication division to something different. Really haven't come up with anything concrete, but several of the ISA symposia that we have for the divisions have had content on the industrial Internet of Things. So, for example, at the Process Control and Safety Symposia that we just had in November in Houston, there were some speakers on different aspects of the IIoT topic. So it's definitely out there. But there's other areas that will come up. So through the years, HMI, alarm management, intelligent device management, those were all ideas submitted by ISA members and said, this is an area where we really should have more guidance, and I think we could pull together the right number of experts and cover this topic. We, in fact, my first ISA Standards Committee meeting was in 2003, and it was for ISA 18, and I had been asked by then Vice President of Standards and Practices, Vic Majoli, who passed away about a year ago. Vic said, Nick, I need you to go and make sure we get an alarm management standard that will help us with our control systems today. I had done a lot of work for that for many years in DuPont, so he sent me to that meeting, and the chair of that meeting said, I'm stepping down as chair because we're starting this new effort around this alarm management topic, and I don't really do that, so we need some people that are willing to step up. And he turned to the guy sitting next to me and said, you're willing to be the chair of the committee? And that was Donald Dunn. He said, well, no, but I'll be a co-chair. And he turned to look at me, and we had never spoken before. He said, will you do it with me? I said, yes. So we walked out as co-chairs of ISA 18, and since I knew a lot of people that had worked on alarm management, by the end of the day, I had 23 people signed up for the committee that were experts in different companies on alarm management. And that's how you do it. You find somebody that's got a passion for it and knows who the subject matter experts are and gets all those people invited to the table, and then you start that process of building that consensus. And I have to say, having been involved in the standard committees, it's one of the best professional development activities I've ever done. I don't regret it at all. It's been a lot of time and effort through the years, but it's also paid off for me in a lot of ways, especially sitting here at a plant in Louisiana, one of our DuPont plants, and we can see the impact of that here at this plant. So get involved in the standard. It's easy to join. You can access them online. Go to view the standards. It's a member benefit. Sign up. You can get involved. You can start off easy where you're just following the email list and until it gets you caught on fire, and then dive in as deep as you can. But you can really contribute. You can really change the world, a little piece at a time, but you can really change the world. So that's a little bit about the amazing world of ISA standards today, Greg.
Wow. Thank you very much. I'm thinking that we ought to have some WebExes on the individual ISA standards and do that as an ongoing thing because of the interest and need for it. So I think this has opened up a door here for us to be doing a lot more through the ISA Mentor Program. And hopefully, since these recordings are going to be available to everybody, there'll be a lot of benefit throughout the Automation Committee and community. Thanks.
Are there any final questions before we end?
I've got one. Nick, this is Hunter Vegas. How are you?
Hey, Hunter, how you doing?
All right. Nick, this is probably a slightly politically incorrect question, but I'm interested to hear it. I've never sat on a committee. I've heard a bunch of interesting horror stories, and obviously some committees are much more politically difficult than others. When the vendors start wading in and everyone's trying to get their agenda, standardized so that they're kind of sitting pretty market-wise. How do you handle that? I mean, is there enough critical mass in the meeting to sit on them? Or, I've heard people get into arguments like word per word. You said this instead of that, and it would be very, very difficult, or can be very difficult. And I was just curious to hear your take on that.
Okay, so what they say about if you want to eat sausage, don't ever go see it being made.
Yep.
So there's some things like that sometimes about standards that are said, but it's very important, and we've on the Standards and Practices Board, we've been working on developing our leaders of our standard committees. But you have to really the chairs have to establish the rules and kind of control that, because you can have very strong personalities in there, people that are very smart but are very antagonistic against other people that are very smart because they have some professional disagreements or they've had some personal disagreements in the past. And so as a co-chair of IS-18, we devised our meeting procedures using a lot of Robert's Rules of Orders to make sure that those kind of interactions didn't take place. But some of the committees, and we've had two notable committees for this, to be honest, in the past. One was the ISA 50 committee that originally did the signals, so they set the 4 to 20 milliamp standard, which was great, right? And then they took on the task of field bus.
Oh, yes.
So the
field bus wars. Yes, and that was one of them that they talked about.
Right. So the field bus wars, and Colin Langford, who Greg and I mentioned earlier, was one of the chairs of that. And then, so that was very politicized, and there was a lot of money for products involved. And then the other one that we got into on the same territory was ISA 100 for wireless. And I was the managing director for the ISA 100 committee for many years. And my role was to come in there as bad cop and say, listen, I've got the reports that you're behaving badly in here. I have the authority to ban you from the committee. You need to play by these rules, and I would go through the rules and say, and you know, if you break the rules, I'm going to come talk to you. And I would come talk to people that broke the rules.
That's funny.
And so yeah, so there can be some of those aspects. Most of the committees are not like that. If you go to the ISA 95 committee meeting, it is the most genteel. I mean, those folks know each other. They all get along. It's just it's quite remarkable, you know. The 84 committee is like that as well. There's very few personal conflicts. They come up every now and then when you have professionals with some disagreements. ISA 101 committee was Dale, you were on that a lot, and that was a very pleasant committee as well, right? There really wasn't much acrimony in there ever, right?
We had some folks with very strong opinions who would make their argument, and then we'd say, okay, let's make a decision based on that argument, and we'd make a decision and it would stand and we'd move on. One of the things, Nick, that really helps is the standards and practices, methods and procedures that's in the Manual of Operating Procedures for ISA. And so there are requirements, at least for voting members of a committee, that you have to have certain representation of producers or manufacturers, certain representation of end users, a certain representation of contractors, solution providers, that kind of people, representation of academics or government or consultants or whatever, and that none of those constituencies can be a majority. And that helps even things out a lot, having those points of view from kind of everybody who's got to touch the thing, whether they make it or buy it or play with it or have to live with it in the field, can get you to some agreements that you might not come to otherwise.
Yeah, and not everyone has that in play, right? So IEC, there's no requirement that it's all by country. There's no requirement that there's a single user involved, and so that's one of the things that ISA is strong in. Now in Europe, there's the Namur group that's also only users. They don't let any vendors play in their space. So ISA is one of the few that is individual membership, and we really seek that balance. And some of those balance requirements are imposed by ANSI because, again, we're an accredited standards development organization. We play by a set of rules when we do that work, and that's what Dale's referring to there as well. So, any other questions or comments before I go to lunch? Well, Greg, thank you so much for the opportunity to talk about ISA standards.
Thank you all.